This is AQA GCSE Coordinated Science Chemistry Higher Paper 2, and this is question 5. Quite a long question. So we start off with an equation here for the reaction between calcium carbonate and hydrochloric acid. Now you would need to know that that makes a salt, and you would need to be able to determine what the formula of that salt is. So calcium carbonate will form calcium salts, hydrochloric acid will form chloride salts, so I know it's calcium chloride. But I also then need to know calcium has a charge of +2, chloride has a charge of -1, so we end up with a balanced formula of CaCl2. Beyond that, you need to remember that a metal carbonate plus an acid makes salt, water and carbon dioxide, so we include the other product in there as well. And then finally, I balance it, I need 2HCl. On to 5.2, you're being asked to describe the trend in this graph, which is a common question, but you're being expected to use values in your answer. So you can't simply say the rate decreases over time until it stops. So let's have a look at how we can get 3 marks. Here's one example. The volume of gas increases for 30 seconds until we reach 60 cm cubed. That's reasonable, we've used values. The rate of increase slows over time, and to bring values in, I've said that it starts to get less steep at around 10 seconds. And we can say that it levels off at 60 cm cubed, no more gas is produced after 30 seconds. And we've moved up to 3 marks. On to 5.3, describe how you would use figure 5 to find the rate of the reaction at 15 seconds. Now, bear in mind, you do not need to do the calculation. You simply need to describe the process that would allow you to do it. First thing you would do is draw a tangent to the line at 15 seconds, and you can see I've done that there. It only touches the curve at that point. Once you have the tangent, you can work out the gradient, and that will tell you the rate. Moving on, give the units for this. Now I've brought forward the information. The Y is volume in centimetres cubed and X is time in seconds. And we know that gradient is change in Y over change in X. So I simply substitute the figures in and it becomes cm cubed over second, or in standard form, cm cubed s to the -1. Moving on to 5.5, a conclusion about how the size of marble chips affects the rate of the reaction. Now we can see that smaller chips react faster. So smaller chips have a greater rate of reaction, and we'll talk a little more about that later within this question. And then suggest why all 3 sizes of marble chips produce a maximum volume of 60 cm cubed of gas. Well, you can see here that we're using the same volume of acid every time. You can actually also see we're using the same mass of marble chips. So if we're using the same amounts of reactants, we're going to make the same amounts of products. So the same volume of gas. Moving on to a question about surface area. And we are told here to calculate the surface of the large cube. And the large cube has a volume of 8 cm cubed. That means that it's got 2 centimetres for its length, breadth and height. 2 by 2 by 2 will take you to the 8 centimetres cubed. So what I can then do is work out the surface area of one face. 2 by 2 is 4. It has 6 faces, so that takes us to 24 centimetres cubed. And then we move on to 5.8. Explain why the size of the marble chip affects the rate of reaction, and you need to talk in terms of collision theory. Well, smaller chips have a larger surface area, and that means there are more frequent collisions. Finally, we move on to 5.9, and we have got here 2 different concentrations of acid and looking at the impact on the volume of gas and on the rate. So why are the results for the lower concentration of acid different from the results for the higher concentration? Well, the first instance, the reaction is slower, so the graph is less steep. It's again because there are less frequent collisions, and that's because there are less acid particles in a given volume. You'll also notice that the lower concentration does produce a smaller volume of gas, again because there are less of the particles to react, so less product will be made.